Now let's look at solve uniform motion problems. The formula for uniform motion is d equals r times t, where d represents travel distance, r represents travel rate, t represents travel time. Okay, so d equals r times t. That's the formula for uniform motion problem. So now let's look at an example. Tanya, who is a long distance runner, runs at an average speed of 8 miles per hour. 2 hours after Tanya leaves your home, you leave in your Honda and follow the same route. If your average speed is 40 miles per hour, how long would you be before you catch up Tanya? How far will each of you be from home? Okay, this is a typical chasing type of uniform motion problem. So before we go through that 5-step procedure for solving any word problem, let's have a brief analysis, okay? So just help you to understand the problem. For a chasing type of problem, the key is both of you, okay, two persons, one is Tanya, I use T to represent, and you, I use Y to represent, okay? So Tanya traveled first. She started first, okay? How much longer Tanya traveled more than you? She leaves 2 hours before you, right? So that means when you start travel or start driving, and then Tanya is already, traveled how far? 2 hours times its travel rate, which is 8 miles per hour, right? It's already 60 miles away from your house. And then you start travel. Because you driving, so your travel rate is much faster. You travel 80 miles per hour, right? So at a certain distance, certain point, you should catch. So let's say here, this is the location you catch Tanya. Okay, so that's, I draw this graph just help you to understand the situation. So in this kind of travel problem, chasing problem, what is the same? That's the key for your identify the model. So Tanya travel distance and you travel distance, that's exactly the same. Okay, the two travel distance is the same because Tanya traveled from your house until somewhere you catch her, right? You travel same from your house until certain point, you catch her. So both persons travel the same distance. Okay, we say the distance traveled by Tanya is the same as distance traveled by you. Okay, that's the key for solving this kind of problem. All right, so now let's go back to the general procedure. Okay, let's identify what we're looking for first. So we need to find the question mark, right? Most likely the last sentence. How long would you be before you catch up to Tanya? So the time, we don't know. The travel time, we don't know. That's the unknown variable. That's only one unknown quantity. So since it's only one unknown quantity and an assigned variable is very easy, let's just say after T hours, you'll catch up Tanya. Okay, so second step is easy to get it done. The third step, we try to translate already known factor into mathematical expression and then identify the model. The model actually we already analyzed earlier. The two persons travel distance should be the same, right? So now let's figure out what is Tanya's travel rate, okay? Tanya's travel rate. And then what is the yours travel rate? Tanya travel 8 miles per hour and then you travel 40 miles per hour. You're much faster. So that's why you're trying to catch her. And then the travel time. You travel time, right? We say, how long would you be before you catch up Tanya? That's the unknown quantity t. So how long Tanya travels? Before you start travel, we talked about earlier, Tanya is already traveled 2 hours. She is 2 hours ahead of you. So the travel time for Tanya should be t plus 2, right? 2 hours more travel time for Tanya. So the distance traveled by Tanya is easy to find out, right? R times t. So that's A times t plus 2. And then how much distance you traveled? Your travel rate times your travel time, 40 times t. And then these two distance, we already said it should be the same. So we now identify equality, which is A times t plus 2 should equals 40 times t. And then we can easily solve this linear equation. AT plus 16 equals 40t. Right? Subtract AT on both sides of equation. So we got a 32t equals 16. T equals 0.5 or 1/2. So after half an hour, and you should catch Tanya. So how far will each of you be from your house? You travel 40 miles per hour, travel half an hour, so you traveled 20 miles, and then Tanya also traveled 20 miles. Okay, you can verify, see if that is true or not. So Tanya traveled 8 miles per hour, and then she traveled 2 hours ahead of you, and then after you start, she runs another half hour, so total 2.5 hours, right? So also traveled 20 miles, which is 20 miles from your home. Okay, and then we solve this chasing problem. And the book provide a very nice graph just illustrating the situation. Okay, and the table pretty similar as the one I did earlier. That's the calculation and verify the answer.